Hello, good morning. This is the subject of distributed systems that belongs to the Cybernetic Engineering program of the LaSalle University. We're going to talk today about the characteristics of a distributed system. First of all, what is a distributed system? There are many definitions for a distributed system. However, there are a couple that I personally like the best. The first one comes from George Coulouris, Jan Dollimore, Tim Kinver, and Gordon Blair. They say, a distributed system is one in which components located at network computers communicate and coordinate their actions only by passing messages. This definition leads to the following especially significant characteristics of distributed systems: concurrency of components, lack of a global clock, and independent failures of components. This definition, as you see, touches several very important aspects of a distributed system, being the main one that it is composed of different network computers that communicate and coordinate between them. Then there's a second definition I like very much. It comes from Andrew Tannenbaum and Martin Van Steen. They say a distributed system is a collection of independent computers that give the final user the impression of constituting a unique coherent system. Again, the key words here are independent computers that give the final impression of constituting a unique coherent system. We are talking about several different computers that work together in order to provide a function to an end user. Let's look at an example. In this case, we have a great example of a distributed system in the web page of LaSalle University. In this case, we're going to have a user that wants to enter the web page of the university. That user connects using his or her computer to the internet. So basically a signal is sent from his computer to the internet. Then from the internet it goes to a specific server in one of the data centers of the LaSalle University. One would think that we have two computers here and that will be enough to prove that it is a distributed system. However, there are more than that. This computer or this server then communicates with another computer that has a database. That database stores information, stores data, stores students or academic personnel information that is shared back and forth between that database server and the main web server. Therefore, that information is also sent to the end user that is connected to the systems through the internet. Then we may have more computers, file servers, other servers that provide different services that then produce information that is sent to the user. So the end user only sees a web page. What she or he doesn't know is that that web page is produced by the collaboration of three different computers in this specific example. This is a distributed system. Now, why are distributed systems built? Which are the objectives of a distributed system? A distributed system has several different objectives. The first one of them is economy. Economy means that putting together multiple computers, one can get the same power of computing that a supercomputer. So the collection of these multiple computers connected to a network is as powerful as one single computer. However, connecting multiple computers through a network has a small cost, basically because of the small cost of the single computers by themselves and the network equipment. However, a very large supercomputer can be a very, very expensive computer or a very, very expensive piece of equipment. So we have the same amount of power on the left that we have on the right at just one fraction of the cost. Then we have the speed. The speed is normally measured in a unit called megaflops. A megaflop is 1,000,000 of floating point operations per second. So megaflops are the real unit used to measure how powerful a computer is. How many millions of floating point operations per second can be produced. So we can also build a very powerful computer by combining the megaflops of small computers connected to them. And in many cases, those small computers, once we add all of their megaflops together, are more powerful than one single supercomputer. So the number of megaflops, or millions of floating point operations per second, produced on the left by a collection of computers connected between them is larger than the number of megaflops that one larger supercomputer can provide. So two of the first objectives of a distributed system are economy and speed. A collection of computers working together are normally cheaper and more powerful than one single large computer. But there is more. There are more objectives for an operating of a distributed system. The next one is inherent distribution. Basically, it means that a distributed design for a software program which is normally complex, can become easier to understand and easier to design, basically by separating the functions of that application between multiple computers that work together connected between them. So that inherent distribution becomes something easier to achieve basically just by putting together multiple computers. Then we have another objective. Reliability. Reliability means that a distributed system is stronger and fails or has a less probability of failing than a larger single computer. Multiple computers provide redundancy at multiple levels. For example, if we have 6 computers connected between them, and one of those computers fails, the work that computer was performing can be then distributed between multiple other computers. So that work is passed to 1, 2, 3, or even more computers, and the total work performed by this distributed system continues without interruption. This allows for a more reliable system, a stronger system, and a system that deals better with possible failures. Then we have another objective, which is incremental growth. A well-designed distributed system, as we mentioned here, can grow as needed without affecting the way it works or its performance. Of course, that means that we have a good design that can allow for a small distributed systems to be able to grow as needed. In this example, in which we have 3 computers, we may find that 3 computers is not enough for what we need to achieve. So we can always extend our network and then add 1 more computer. And then keep working with 30% more of power that we originally had. If by any reason 4 computers is not enough, then we can always extend our network and then add 1 more computer or even 2 more computers and then double the size of the distributed system. Once we do it, we will have a distributed system twice as fast, twice as powerful, twice as large, and that can grow in incremental pieces every time we need it. Another objective of a distributed system is the sharing of components. Basically, because all of the computers are connected to a network, it happens that not only computers are connected to a network. We can add additional devices that then can be shared between all of them through the network. For example, we can extend our network and then add a printer. That printer can be shared between all of the different computers, and then all of them can print paper in one single printer without problem, sharing the resources between all of them. Then if we need additional shared components, we can always extend our network and then add a database server, for example, or a storage server. So all of these additional components can be shared between between the servers or computers belonging to a distributed system. Since all of them are connected through a network, all of them can share those same resources. Then we have another objective: to have an open and heterogeneous architecture. It means that multiple computers of different types, different operating systems, and different manufacturers can interact together in a simple system just by being connected through a network. So, for example, we may have a computer running a Linux operating system, which then connects to a computer running Windows through a network. So they exchange information, they work together. But then if the system is well designed and well planned, we can always add another computer running an iOS system, such as a Macintosh computer, an Apple Macintosh computer. Then we can always add more servers or more devices, such as mobile devices running an Android system, as well as multiple different other servers, 1, 2, 3, as many as we need, as long as they have the same kind of software that is part of a distributed system. So we can have multiple computers of different platforms and different systems working together, collaborating between them, and exchanging information. This is what an open and heterogeneous architecture means: to have multiple computers, multiple systems, multiple architectures working together and interacting together in a simple system, just as if they were one single system. Then last but not least, we have one final objective of a distributed system. Basically, the last objective is an efficient handling of concurrency. That means that a good design allows multiple computers to handle the access to a shared resource in an efficient and controlled way, so each one takes a turn to use the shared resource without any conflict between them. For example, let's say that we have 4 computers that need to use a scanner. Using an efficient and well-planned distributed algorithm, one computer can use the scanner for a specific time. Then, as soon as this computer stops using the scanner, then another computer can start using that same scanner. And they take turns, one at a time, to use that shared resource. So when this computer stops using that shared resource, it basically frees it up, and so other computer can use it. And once this computer stops using it, it leaves the device available for the last computer to use that same shared resource. So basically, this is the last objective of a distributed system: an efficient handling of concurrency. As we mentioned, distributed systems are very important nowadays, basically because of all of the power they have, because of their flexibility, and the fact that they can allow multiple computers connected through a network all over the world to work between them. Thank you very much.